Hello everyone and welcome to another discussion on our series on LabVIEW. What we are interested in today are for loops and timing delays. Let's go ahead and create a for loop right away. As you can see, we would want to go into structures, and there you have them. You could begin with a simple drawing of the for loop, and you could see some of the parameters that come along with it. First off, you see a loop count, which is basically something that lets you control how many loops do you want or how many iterations do you want your program to run. What you have here is a loop iteration, which gives you exactly which iteration number is currently being executed. Okay, the fundamental concept of for loops is that you keep executing some code again and again. So how many times do you want to execute that code? That is a parameter which can be controlled from here. And exactly which iteration are you currently on, which iteration is currently being executed, that information is stored here in the loop iteration variable. Okay, so let's go ahead and have a simple program for us, and let's put in some constants. Maybe let's just add them up. Let's add two constants. Let me get an adder. Okay, there you are. In fact, instead of adding two constants, let's just add the iteration number right away. Okay, and let's give this a value of 1, and let's display our numbers. I'm choosing an indicator because I want these numbers to be, it's going to indicate what is the value here, so, and I don't need to control them, so it's just going to display my answer, right? What is there something that I'm missing? As you can see, there's something that I'm missing. My program does not know how many times do I need to loop this. Okay, so maybe I can devise another numeric constant here and feed in a value. Perhaps I want to just loop this over 5 times. All right, so what do I expect my program to do at this stage? I am expecting it to run from some iteration number, maybe that starts with 0, and 0 plus 1 should result in 1, and then for the next iteration it should result in 1 plus 1, 2, because for each loop iteration I'm going to get an increment in the loop iteration variable. A good practice perhaps could be to have this displayed as well. All right, so maybe we could go ahead and display this. Right, so here we're going to make sure we know which iteration we are on. And here we are going to know what is the value of the sum, right? So let's go ahead and run this. Notice how I, instead of choosing run continuously, I'm just going ahead with the run, because this is going to iterate 5 times. So I could just run it once and let it iterate 5 times. I don't have to make it, I don't have to run it continuously to keep it iterating for 5 times and then another 5 times and another 5 times, right? So I'll be happy to just go ahead and run it once so that this just loops 5 times. Okay, so what's going on? Each time we run it, it just tends to give us a sum of 5 and iteration of 4. Notice that these are the results of the very last iteration. Okay, so iteration number begins from 0, 0, 1, 2, 3, 4. So those are the 5 iterations, and this is the last iteration, iteration number 4. So 5 iterations have gone in, and the last iteration is iteration number 4. It starts from 0, so 0, 1, 2, 3, 4. Those are 5 iterations. So 4 plus 1, 5, and that's what the sum is correctly representing. So it turns out that the for loop is running so fast that it just gets to the last iteration and we're unable to see the iterations in between. So one of the things that we could actually do is we could perhaps introduce some timing delay, and that is what I'm going to do right here. I'm going to introduce some time delay of say 1 second. All right, and time delay, yeah. So I could introduce some time delay. Double clicking on it lets you configure how much delay do you want in seconds. So if I just choose that as it is and then I run it, so you could see iteration is 0, 1, 2, 3, 4, right? So and it takes 1 second for each iteration to get executed. And now I'm able to see my iterations, my for loop looping through them, and I can easily keep track of what's going on. All right, another important aspect that could be of interest to us, and it usually is the fact that you could right click on your for loop and you could choose to add a shift register. Okay, so you could perhaps add another element to it, and then you could have multiple of these shift registers. What are these shift registers? So each time you loop from one iteration to the second iteration, these shift registers allow you to carry some values from one iteration and make them available in the next iteration. So the best way to understand this is through an example. What I'm going to do here is I'm going to set up a connection with my sum variable. Okay, so I'm going to set up a connection here with the sum in this register, and what that basically does is in iteration number 0, if we go ahead and start from all the way from the start, so what I've done is I've paused my program. By pausing my program, I'm able to stop the execution, like pause the execution right there. So at iteration 0, what goes in from here is 0, and I have one constant here, so 0 plus 1 is 1. That is why the value of sum is rightly so 1. Okay, and that goes into my shift register. Now in the next iteration, when iteration goes to, let it go to 1. Okay, so in the next iteration, when iteration goes to 1 and the sum is 2, and the 2 is going to be fed into this shift register for the next iteration, remember this side, the register on your left hand side, is going to allow me to access the value that was available or that was fed into this register in the previous iteration. So if I were to represent this value, if I were to choose an indicator and set it up here, and in fact just display this particular value, what I would actually see is an iteration. What I would actually see is a value fed to this register from the previous iteration. Right away you can see, although the sum is 2 is being fed into this register, but what you see in the previous indicator right here is the value of sum that was available in the previous iteration. So whatever sum was equal in the last iteration, that is going to be available from this shift register. So in the previous iteration the sum was 1 was stored in the register, and in the next iteration we were able to get that value 1. Okay, so right now the value of sum is 2. It's going to get stored in this shift register, in the next iteration, when iteration goes to 2, in the next iteration, when sum equals 3, we will be able to recover our previous value. Okay, so I'm going to let it run and let you see that each time you are able to feed a value in the shift register, you can easily recover that value in the next iteration. So that is one way to use shift registers, and by timing delays you're able to view them nicely. If there are any questions, I would be happy to answer them. There are certain problems that will get you up and running in the description of this video. I'm looking forward to hear your comments and looking forward to our discussion. Thank you.